Dear students, today I want to discuss with you the very important derivation. That derivation belongs to electric dipole, and in this derivation we have to find the electric field of dipole on equatorial line. That means today's topic is electric field of dipole on equatorial line. Children, derivation becomes very easy if the figure or diagram is clear in the mind. So first of all, I will explain here the diagram. As for the topic, the very important thing is dipole. So first of all, draw the dipole. For dipole, I will take two equal and opposite charges, because as you know students, dipole means what? System of two equal and opposite charges separated by a small distance. I am taking that distance as 2a. Also I am taking the midpoint of the dipole as O, and if O is the midpoint of the dipole, then the separation of minus Q from the midpoint will be A, and the separation of plus Q from the midpoint is also A. So this is the first thing of the derivation. You have to know how to draw the dipole. And as you know, dipole means equal and opposite charges, and the strength is given by the dipole moment, and dipole moment is a vector quantity and its direction is minus q to plus q. That's why here I am writing dipole moment as vector and its direction is minus q2 plus q. This much is sufficient for dipole. Now let us come on the second part of the topic, equatorial line. You have to keep in the mind what is the meaning of equatorial line. Equatorial line means what? The line which passes through the midpoint of the dipole and it is perpendicular to the dipole also. So that's why now I am taking one line which passes through the midpoint and it is perpendicular also. So this is the another part of the topic. But on equatorial line means you have to take some point, and that point I am taking as P. So P is a point on the equatorial line. Also assume that it is at a distance r from the center or midpoint of the dipole. P point is at a distance r. Okay, so that's why as per the diagram, it is very easy for you to find the distance of minus q from P. As per the Pythagoras theorem, it is r, this is a. So this distance is r square plus a square raised to 1 by 2 as per Pythagoras theorem. In the same manner, the distance of plus q from P point is also r square plus a square raised to 1 by 2. And I think children, it is clear from the figure, both the sides of the triangle are equal. Hence the triangle is isosceles triangle and if isosceles triangle you have, then angles opposite to equal sides are equal. That's why now I am assuming angles as theta. Okay. Now let us come on to the third part of the topic. You have to find electric field. Children, whenever you have to find electric field, the important thing is the direction, and hence now I am taking the direction into consideration. In the earlier class, you studied that whenever you have minus charge, then the field is inward. So that's why now I am taking the direction. So this is the direction of electric field of minus q. It is inward. It is inward. And for positive charge, the field is outward. So this is the direction of electric field of plus q. Okay. But as in this case we have two direction of electric field at a particular point, and at that point only we have to find the electric field. So that's why here the very important thing is principle of superposition. And as per the principle of superposition, we have to do the vector sum of both the fields, that is the field of minus q and the field of plus q. Okay. And for that you have to complete the parallelogram like this. And when you complete the parallelogram, the diagonal gives the direction of electric field. So this is net electric field. But when you want to do the vector sum, the very important thing is the angle. And here angle is not given. Okay. That's why whenever children you have this type of case, keep one thing in the mind. Let us resolve both the vectors. So how to resolve both the vectors? For that, just see in the figure, this angle is theta. So if this angle is theta, so this angle is also theta, because alternate interior angle. And when you resolve this E minus Q, okay, for that I am taking the sub diagram, and for that this is the electric field of minus Q, and as per the figure, this angle is theta. So that's why when you resolve E minus Q, so you have two components. This is E minus Q cos theta, and this is E minus Q sin theta. So this is the case of electric field of minus Q. So when you resolve that vector, you have E minus Q cos theta and E minus Q sin theta. Now let us move on to E plus Q. For that, when I extend this line in this manner, so now this angle is theta, so it is clear from the figure, this is also theta. And if this is theta, then this angle is also theta, vertically opposite angle. So now I have this E plus Q, and this angle is theta, and that's why when I resolve E plus Q vector, this is E plus Q sin theta, and this is E plus Q cos theta. And from this diagram, I think children it is clear to you all that sine components cancel out. and the cosine components add up. And I think it is also clear from the figure that the magnitude of electric field due to plus Q is equal to the magnitude of electric field due to minus Q. And that's why it's very easy for me to write that the magnitude of net electric field is 2 times the magnitude of electric field due to plus Q and cos theta. Why it is cos theta? Because I think it is clear from the second figure that cosine components add up and sine components cancel out. Now the value of electric field due to plus Q, so it is as per electric field due to a point charge. And what is the formula of electric field due to point charge? It is kq upon r square. That's why it is kq. And in the denominator r square, so what is the distance? R square plus a square is to half, and the square of that is r square plus a square. So I am writing directly here, it is r square plus a square. And I think it is also clear from the diagram that the value of cos theta, so this is cos theta. So cos theta means what? Base upon hypotenuse. So this is theta, so base is a and hypotenuse is r square plus a square is to half. So I am writing here a upon r square plus a square is to half. Children, earlier you studied that dipole moment is given by q into 2a, and same you are getting here. This is q and this is 2a. So now I am replacing q into 2a by p. So I have k into p, and in the denominator the power is here 1. So 1 plus half, it is 3 by 2. So final answer is r square plus a square raised to 3 by 2. This is the magnitude of net electric field at point P. But children, you know that dipole length is very small, and as dipole length is very small, the condition is R is very greater than A. This is for the small dipole. And if I apply this condition, okay, so net field will be Kp upon R square raised to 3 by 2. So 2 cancel. So net answer is Kp upon R cube. But children, this is the magnitude only. But as you studied earlier, electric field is a vector quantity. So at the end, I will write the vector form. How to write the vector form? So vector form means what? Electric field and dipole moment. So I think it is clear from the figure that dipole moment is in this direction, towards right, whereas the net electric field is towards left. That means dipole moment and electric field are opposite in direction, and that's why the vector form will be net electric field is minus Kp upon R cube. What this minus sign represents? That electric field and dipole moment, they are opposite in direction. I think children, this diagram A, B and derivation all are clear to you. Thank you.